Myself, Dr.Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. Students, today we will be discussing vernier caliper in a virtual setup. For this purpose, we are using simulation which we can download from Microsoft Store. Students, you can also design your own vernier using this simulation. Vernier caliper is a very basic instrument which is used in BSc as well as MSc labs. So students, it will be beneficial for all of the students which are interested to learn physics, to learn about the vernier caliper. Here I am showing you vernier caliper. This is a basic vernier caliper. When we use a scale to find the length of any object, here as I have shown a box, and we are determining the length of this box using a ruler. But do you think that it will give the accurate measurement of length of this box? No, this will not give the accurate and precise measurement of length of this box. This ruler will also not give the precise measurement of height or width of this box, or we can say of any of the object which we are using. So, in order to find the precise measurement of either the length, width, height or diameter, we have to change the tool which we are using. For this purpose, we will use vernier caliper. Vernier caliper is a measuring tool that will give an additional accuracy to the measurement as compared to a ruler. Now, I am going to discuss about the vernier caliper. This is a vernier caliper. This vernier caliper can also measure the thickness or depth of small objects, as well as we can see here that it can measure the inside and outside diameters of tube. For example, here I have shown a tube which is hollow from inside. Using this vernier caliper, we can measure inside as well as outside diameters. So students, now I am going to tell you about the various parts of this vernier caliper. It comprises of the main elements which are main scale, vernier scale, thumb screw, lock screw, depth rod, fixed jaw and sliding jaw. Now we will discuss about these various elements of vernier caliper. This vernier caliper consists of a long steel polished ruler. This ruler is termed as a main scale. It is generally 15 centimeters long. Here we can see that this is our main scale. This main scale, it is graduated in inches at the upper end and it is graduated in centimeters in the lower end. Now we can clearly see that on this main scale there is another small scale. This small scale, polished steel made scale, this is termed as vernier scale. I will show you the vernier scale here. This is our vernier scale which is moving on the main scale. Main scale is fixed. Vernier scale can slide using this lock screw which is on a vernier scale. The other parts are, there are lower jaws which are used for outside measurements. One of the jaw is connected to a vernier scale. The other jaw is connected to main scale. The other jaws, which are the upper jaws, they are used for inside measurements. As I have said that we can measure the inner diameter and outer diameter of a cylinder. So, using these two types of jaws, lower jaw and upper jaw, we can easily measure the diameter of a cylinder. And there is a rod at the end of this metallic scale. This rod is termed as depth rod. We can measure the depth of this cylinder using this depth rod. So, these are the various elements of our vernier caliper. Now, we will find the principle of vernier caliper. As I have shown, using a scale that we cannot easily determine with an accuracy the length or breadth of any of our object. For example, here I am showing this is our object, which is rectangular in shape, and we have to find out its length. Then if we use a vernier, I am going to show you in my further lecture that how will it determine its length. It can determine the length of this object with an accuracy of 2 decimal place. Now, I will find the least count of our vernier caliper. We know that least count is defined as the smallest distance that can be measured from our instrument. From a simple scale, we can measure a distance of 0.1 centimeter accurately. But with this instrument, if I am going to find the least count, I will show that we will find the length, breadth accurately up to 0.01 centimeters. The formula for the least count is value of one main scale division divided by total number of division on vernier scale. This is our main scale. The long metal strip strain scale is the main scale. It is graduated in centimeters. This is 0 to 1 centimeter. So, the value of one main scale division, it will be, if I measure it in millimeters, then it will be 1 mm, and this is divided by total number of division on vernier. On a vernier scale, we can see that there are total 10 divisions. So, the least count will be 1 mm divided by number of division 10. So, it will be 0.1 mm is the least count of our vernier caliper. That means least count of vernier caliper is 0.01 centimeters. Now, we will discuss another important aspect of vernier caliper. It is zero error. Zero error is a mathematical error which we will find using this simulation technique. I am completely closing the jaws and assuming that let these two jaws are connected and there is no object between them. So, we can clearly see the 0 of these two scale. This is the 0 of main scale and this is the 0 of vernier scale. The two 0, they are coinciding each other. When the 0 mark of the vernier scale coincide with the 0 mark of main scale, then there is nil error in the vernier. but I will show the two conditions. But if the two zeros do not coincide, then we can say that our tool, an important tool, vernier caliper, is having some zero error. These two error are positive zero error or it can be a negative zero error. In this condition, I have shown no zero error condition. The zero of main scale we can see is coinciding with the zero of vernier scale. So, our this kind of vernier caliper, as shown in both figures, they are free from any error. Now, I am going to tell you about the positive zero error. When this type of condition arises on closing the jaws, then if the zero of the vernier error, vernier scale, this is our vernier scale and this is the zero of vernier scale, if it is ahead of main scale, then there exists a positive zero error. I am showing this type of zero error in my this vernier. Suppose there is no object in between the jaws, then we can clearly see that both zeros are not coinciding each other. That means there is some error, zero error in this type of vernier caliper. When both zeros are not coinciding and the zero of the vernier, this vernier scale, is ahead of zero of main scale, then in this condition there is a positive error. And how do we calculate this type of error? I am showing here. The third line, I am counting from vernier scale, the third line is exactly coinciding with the line of a main scale. That means our coinciding division is 3 and we have already determined our least count. The least count of screw gauge of vernier caliper is 0.01 centimeters. Zero error is calculated by multiplying the coinciding division with the least count. The coinciding division I have shown is 3. It will be multiplied by 0.01. So, the zero error comes out to be 0.03 centimeters. This is termed as positive error. Positive zero error occur when the zero of vernier is ahead of zero of main scale. Now, I am going to tell you about the negative zero error. When we are closing the two jaws and we can here see that zero of 2 scale, they are not coinciding. This is the zero of main scale and the zero of vernier scale is on the back side of zero of main scale. Then this type of error is termed as negative zero error. Now, how to calculate this type of error? Here we can see both type of scale and we have to find out the coinciding division in the both type of scale. Coinciding division means the two lines which are exactly meeting at a point. Here we can see that 8th division of vernier scale is exactly meeting a line on a main scale. Hence, coinciding division will be equal to 8 and the difference will be counted as total number of division minus the coinciding division, which is 8, and the total divisions on vernier scale is 10. So, 10 minus 8 will give me 2. So, the zero error will be 2 multiplied by least count That means 2 multiplied by 0.01, it will be 0.02 centimeters. This is a negative zero error. The negative zero error occur when the zero of vernier scale is on the back side of zero of main scale. Now I will show how to take the readings. Now I am putting my object between these two jaws of vernier caliper. For this purpose, in order to fix an object between the jaws, I have to open this. So I am moving my vernier scale so that my object get fixed between these two jaws. I am taking an object so that it gets fit between these two jaws. This is my object, and as I have shown that value of main scale division, it is equal to 1 millimeter, and there are total number of 10 divisions on this vernier scale, and we have find out the least count to be 0.01 centimeters, or in millimeters it is 0.1 millimeter. So now my aim is to find out the length of this object. The length of this object will be determined using main scale reading and vernier scale reading. Here I am assuming that there is no zero error. So here the main scale reading will be, this is the 0 which is appearing here. The 0 comes after the 8th division. What does this 8th division means? 8 millimeter or 0.8 centimeter. When we are measuring in centimeter, it will be 0.8 centimeter, and in millimeter it will be 8 millimeter. Now I have to find out the vernier scale reading. Vernier scale reading means coinciding division into least count. The coinciding division means the number of division on vernier scale which exactly coincides with main scale. Here we can show that first division is exactly coinciding. That means they are making a straight line. The other divisions, they are not making a straight line because there is a slight difference between them. So vernier scale reading will be 1 multiplied by least count, that means 1 multiplied by 0.1, it will be equal to 0.1 mm. Hence the total reading will be, formula for total reading is equal to main scale reading plus vernier scale reading into least count. It comes out to be 8.1 millimeter. That means 0.81 centimeter. So if we calculate the length of this rod using a simple scale, it will come out only 0.8. Here we have accurately determined with a convenient tool that the length comes out to be 0.81 centimeter. So using vernier caliper, we can determine the length of any object accurately and precisely up to 2 decimals. Now I will show how to incorporate our zero error. In the first figure, I am showing a rod which is having no zero error. That means I am having a vernier in which if I am closing the jaws without any object, then the two zeros are coinciding. This is shown in the figure as I have shown here. Now I am going to find the length of an object. To determine the length, I am placing my object between the two jaws. So using a object between the jaws, I am fixing my object between these two jaws. I have fixed my object between these two jaws. This is the first condition which I am showing without any zero error. The main scale reading I am going to find using this instrument is the main scale reading which I am getting. This is the main scale and this is my vernier scale. The vernier scale, we can see it is coming on 3.14 centimeter. So the main scale reading is 3.1 centimeter. Now I have to find vernier scale reading. For this purpose, I have to find the coinciding division. I am seeing from the first line it is not exactly matching with the lines on the main scale. Similarly, the second and third, they are not matching. Fourth line is exactly matching with the line on a main scale. The other lines which are after 4, they are also not matching. So I have my coinciding division to be 4. This 4 is multiplied with least count. I get 0.04. So the total reading will be 3.14 centimeter. This is the reading of the length of this rod which I have find out in a situation when there is no zero error. Now I am taking my second condition. My second condition is of a zero error, the positive zero error. Here the zero error which I am finding is, I am first of all, in order to find the zero error, first of all we have to remove the object and close our jaws. So I am removing the object and closing my jaws. For this purpose, we have to slide a vernier scale on a main scale and we have to find out the coinciding division. I am closing my jaws. And suppose this is the condition on closing the jaws. We can clearly see that two zeros, they are not coinciding. The 0 of vernier is ahead of 0 of main scale. So this is the condition which I have shown is of positive zero error. And the coinciding division is the third line. The third line of vernier scale is exactly coinciding with the line on main scale. So here the zero error will be 3 multiplied by 0.01, that means the zero error will be 0.03. Now in order to find the reading of the length, we are opening the jaws and placing the object in between these two jaws as we have done earlier. So I am placing my object and finding the length by placing it in between them. So this is the condition. The length will be determined using this convenient tool which is a vernier caliper. The main scale reading here is 3.1 centimeters and the coinciding division is coinciding division which I am showing is on moving. We are fixing our setup. Coinciding division is the third division. So 3 multiplied by 0.01 give me 0.03. As the total reading comes out to be 3.13 centimeter. And we have determined as zero error also, which we have to take into account. The reading, exact reading will be 3.17 centimeters. The error was of positive, so it can be subtracted. 3.17 minus 0.03, it will give me the actual measurement of the length of this rod is 3.14 centimeters. Similarly, we can find the negative zero error. The negative zero error occur when the zero of the vernier is behind the zero of main scale. This is the condition of negative zero error. Here we can determine the coinciding division, which will be 10 minus 7, it will be equal to 0.03 will be the zero error. Here I have shown the negative zero error. The length, the actual length which is the measured from vernier is 3.11. So 3.11 minus bracket mein negative zero error, it will come out to be 3.14 centimeter. So this is the way how can we determine the value of length of any object using vernier caliper. Now we will discuss about the precautions that should be used in the vernier caliper. The first error that can occur is when we place an object and we are seeing the object and vernier caliper, then this error occur when an object is observed with an angle. Now we can take a wrong reading on a measuring scale because we cannot fix our eye on any particular position. So in order to eliminate this error, we should have a position of eye directly above the scale when we are taking the reading on main scale and this vernier scale. Another error which can occur if we use different types of units. For example, here I am showing that we have to find the length of a rod and I am opening my jaws in order to find the length of a rod. This is my rod which is placed between the jaws. If I am finding the main scale reading and I am noting it as 0.6 centimeters. This is the main scale reading because the zero of vernier is coming here after the 6th division on main scale. Hence the main scale reading will be 0.6 centimeter. And now I have to find the vernier scale reading. In vernier scale we have to see the coinciding division. The coinciding division means the line which exactly matches with the line on a main scale. Here we can see the line that is matching is 7th line. This 7th line is multiplied by a least count which is 0.1 mm. So the vernier scale reading will be 0.7 mm. Earlier we have taken a reading, main scale reading 0.6 centimeter. Sometimes we add up a main scale reading to a vernier scale reading without seeing the units of the two readings. We have to take a reading in one type of unit. So we have to take in a unit in another system. It is more convenient to appropriate unit. That means I have to change my reading which is in millimeters in centimeter. So the actual reading will be 0.07 centimeter and the length of this rod will be 0.67 centimeter. The other precaution which we have to take is to avoid the excess force on the jaws. when we are fixing an object between these two jaws. This is very important because if we are sliding the scale and moving the jaws, then we can deform the shape of the object which we are using, because a wire if we are using and we are pressing the jaws tightly, then we can deform the shape of a wire. Another precaution which we have to take is that while using a vernier caliper, first of all we have to find the zero error. Zero error must be initially calculated. Another precaution that we have to take is that object which we are using, it must be completely cleaned and dried with a cloth soaked in cleaning oil. Now, the last precaution that we have to take is when we are losing the locking key, we must assure that there is no friction between the scales while moving the jaws, because these two scales, main scale and vernier scale, they are made of steel. So, friction can develop between these two type of jaws. So, while using a vernier caliper, we have to take a precaution. So, students, I hope you must have understood about the working of vernier caliper, its least count, and how to measure the zero error and the reading using a vernier calipers. Thanks a lot for watching.